The last pre-calc class asked for this question, and we ran out of time because I couldn't figure it out within the last 5 minutes. But it's not too bad. Once I sat down and thought about it, the hardest part was trying to figure out what the heck is going on. It's this question here. If you haven't got there yet, it's this problem. Uh, so there's a hot air balloon floating in a straight line, and they're looking down at 2 mile markers. Okay. I use these angles because that's the one they asked for. With the angles of depression, so they're looking downward. Okay. So you can change it. You're gonna have to change it to miles at the end, or you could change it right now. It doesn't matter. So I guess picture the balloon as this is the mile marker 1, mile marker 2. Okay. These are the two angle of depression. So we use tangent twice, set it equal to the height. So basically you make two triangles, an inner triangle and an outer triangle. Once you do that, you can set these two equal to each other and solve for x. Once you have x, you plug it in and you'll have your height. Okay. So drawing this part was the hardest part, but once you have it, it's no big deal. Let me move that mouse pointer. Tangent of 20 will be the height over x, right? That's right here. Solve for height because that's what we want, but it has two unknowns. So I can't do anything else here. So then I say, okay, well, picture a bigger triangle. Tangent of 17 will be opposite over x plus 1 because this is the mile marker right here, A and B, 2 mile markers. So this distance is 1 mile. This distance is x. I don't know what it is. So what you can say is 1 mile plus x. So the opposite side over this adjacent side, this entire bottom. Do you see how we set this up? Okay, so that's why I put 1 mile plus x. Over here, I just went ahead and just left it as 1 because it's kind of messy writing 1 mile. Just understand that all of this would be in miles. So does this setup make sense to you? Yeah, this is the last question in 5.4, I think. Yeah. Or maybe 6.2, I don't remember. Let me check. Yeah, 5.4. Final problem on 5.4. Is the setup okay? Yes.
Would it make a difference if instead of h over 1 mile plus x, it's like already from
No, that's what I'm saying. You could convert to feet now if you want to. You just have to put the 5,280 here.
wouldn't like
No, you have to change it at some point. You can change it now or at the end. If I change it at the end, I don't have to write the big number. That's why I left it as 1. But it doesn't matter. But anyway, so if that part makes sense, if you have two different things equal to h, that means those two things can be equal to each other. So set tangent of 20 equal to 1 plus x tangent of 17. To set these two equations equal to each other, solve for x. I'm just going to distribute this tangent on both of these terms and move over anything with an x to the left-hand side. So 1 times tangent plus x times tangent. Subtract this guy over, and then I'll have everything with an x on the left-hand side. So minus x 10 17. Factor the x out, and we'll be almost done. This is tangent 20 minus tangent 17 equals to tangent 17. Divide this garbage over here, and you'll be done. Divide both sides by this. So divide by tangent 20 minus tangent 17 on both sides. So this will be gone. So x is equal to whatever this is. So at this point, you need your calculator. I think it's like 5 something. I don't know. Okay. Tangent of 17. Okay. Yeah. 5.249. We'll round to 5.25. Okay. Now, this is in miles, right? Because I left it as a 1. If I would have changed it, this would have been different, but it would be in feet. The question on the Homer wants it in feet, so you would have to convert it here if you didn't do it up here. Okay, does that make sense? So how many feet is this? So to convert, there's 5,280 feet in a mile, right? 7,000. So every mile has this many feet. These would cancel. 5.25 times 5,280. 27. So you said 27,000. Yes.
On the second line, where it's 10, 17, 6, how'd you convert that top one to that?
Right here. This line. Multiply 10 times the 1. It gets me here. 10 times the x gets me there. And then subtract this part over here. And that's what we got there. Does that make sense? I didn't show some of the in-between steps, but that's what happened. At this point, you factor x out of both here. Then you divide this. This is just some number, right? It's like a 4 or something, whatever. Divide by 4 or some number, both sides. Then you get x. I don't know what it is. Not 4. It's some number. I'm just saying. Okay. Anyway, that was one of the hard ones. I did delete some of the weird graphing questions. I don't know if you noticed. They should be gone now. If you're logged in right now, you should see. I think it was like 6.2 had some weirdo questions. But anyway, any question on this one? It's okay. All right. Anything you're still struggling with? You want to work on? Okay. Wait, I'll let you guys look one up. Or if you want to just work on problems and let me know, that's cool too. Yeah. You have one? What section? All right, so I have 5.4 open. Let me look. It's what problem? Is that the plane? Which one? The hill? Okay, let me zoom out so I can see the numbers. Oh, this guy. Okay. Wrong button. I want the picture right here. Okay. So reverse the right triangle in the figure. Okay. He says number 12, right? Okay. Let me draw this picture. B, C, A. On yours, what do they have for AC? You can use your numbers if you want. AC or BC? Oh, okay. BC equals 10. And angle what? 20? Okay. It's almost like this one, but they put BC right here. Okay, then. And they want us to find AB. BC. Okay. We already have BC though, right? Okay. On yours, they want AB and AC? Okay, so this one's different. Got you now. All right. Thanks. Okay, so BC is referring to this side over here. So this side is 10. That's all we got from them, except this angle is 20 degrees, right? Okay. Find the missing side. Missing two sides in the other angle. The angle's not too bad, right? Because we technically have two angles, so we should be able to find the last one by subtraction. So alpha is going to equal 180 degrees minus the other two angles. So 90 minus 20. That will be 70, right? That one's not a big deal. 70 degrees. Okay. We have the opposite to 70. So we can use that to find the hypotenuse. You can also use tangent to find, or cosine. No, not cosine. Tangent or sine to find this side. Doesn't matter. I'm going to do sine of 70 degrees. That will be equal to the opposite side over the hypotenuse. They're calling this AC. Right? This line segment is AC. So do your algebra and find AC. Multiply both sides by AC. That'll get us to here. Divide by sine 70. On both sides. So AC will equal 10 over sine 70. I don't know what that is. $10.64. Okay, so we got one answer right here, one right here. Okay, any questions on that setup? This part okay? For AC, it should be 10.64. I don't know how many decimals they wanted. The 5 or 3? Mine says 3. I don't know if yours is different. So put a 2 right here. 10.642 would be 3 decimal places. Okay. So I'll find AB. So we can use so all this right here, solving for AC. Now let's use a tangent of 70. That'll be equal to 10 over AB. Right? Opposite over adjacent is tangent definition. 10 over AB. Now do the algebra again. Isolate AB, just like before. Multiply both sides by AB. If you want to do a cross multiplication or something, that's fine with me. Just be careful. I don't really care. Divide both sides by tangent 70. So AB is equal to 10 over tangent 70. About 24 or 27.475. This is AB. 27.475. Okay. Any questions on the algebra or the setup? That okay? Okay. Any other questions you guys are stuck on? Yes.
5.4 or 5.3, 22.
5.322. That towards the bottom? Which one was it?
Yeah.
This one? Okay. Let's do it. So what section was it again? 5.3, problem 22? Okay. So they give us tangent. Theta is equal to 5/4. And what's up? AB? I'll check in a sec. The other one was fine? Tangent 5/4. All right, let me double check real quick. AB let's see. Tangent of 70 degrees should be opposite over adjacent. 10 over AB. Cancel these guys. Divide by 10, 70. You put 27.475? Double check. Yeah, okay. Oh, yeah, I did screw up. I hit times instead of division. My bad. It should be 3.63. Then you're rounding that guy to the next decimal point, so 3.64. Which makes sense, right? How would that be bigger than the hypotenuse? We should have cut that right away. 364. Sorry about that. Okay. So they're telling us that tangent is 5/4 and it is positive, right? So which quadrants is tangent positive, but sine is negative? What quadrant is that? Yeah, I think it might be 3. Let's look at it. In order for tangent to be positive, either both y and x are negative, or both y and x are positive. So it has to be quadrant 3. Yeah. Which means that cosine is also negative. So these two hints that they give us tells us that we are in quadrant 3. Which means that x and y are negative. Hypotenuse is never negative. But these two are negative. This is my opposite and adjacent. Okay. Find your hypotenuse. Okay, plug in your numbers. 16 plus 25. What is that? 41. Okay. So just plug in. So now by definition, sine is negative 5 over 41, root 41. You rationalize, this would be negative 5 root 41 over 41. Cosine will be 4 over negative 4 for square root 41, which is negative 4
square root 41 over 41. Secant is the reciprocal of cosine, right? So just flip this guy over. 41 over 4. Cosecant is reciprocal of sine, so flip this one over. Cotangent would be this reciprocal. That would be it. Any questions on 22?
The tangent was final numbers. Second.
If secant sine was negative and tangent was negative?
No. Oh, yeah.
If they're both negative, it would have to be quadrant 4, right? Let's look up this. Look at our circle. Because in order for tangent to be negative, only one needs to be negative, right? And we want sine to also be negative, so we would choose quadrant 4. Yeah, so that would dictate quadrant 4, which would then mean that this value here for cosine, the x value would be positive, so that would change. Which one did you use? The rationalize, or
Yeah.
you put -5 root 41 over 41? Try the other one, I guess. This should be good though, unless you punched it in weird. I don't see any issues with the algebra here. Squaring these would be 16 and 25. 35 plus 6, 41, yeah. Doesn't reduce. Should be good. I took the rest.
And
See? Oh, your tangent is negative.
oh,
That would change. So I guess mine was good.
yeah. I'll think.
I guess next time I'll just should take your numbers. Anyway. But the idea makes sense.
Yeah.
Any other questions you guys want to work on?
I have the same one, but my tangent is -7. And then one side is greater than
-7 over 2. And your sine is greater. So what quadrant would that be? Right, if tangent is negative, that means one of them has to be negative, x or y, but they tell us the y part is positive, so has to be over here, right? Quadrant 2. Once we know that, we can build the triangle. That'll be exactly the same. Quadrant 2. So sine is positive, Cosine is negative, so put the negative here. Find the hypotenuse and you should work out. But you see how that's the key, right? Finding what quadrant we're in. I mean, I'll give you the hypotenuse and then we'll move on.
Instead of using like, yeah,
Mhm.
you can't you just do like tangent? Use-
Yeah, like the solve for the triangle. You could, you just need an angle.
Oh,
If you don't have it, then no. So yeah, just use this to find the trig functions. It's like we did over here. Okay. Any other questions you guys are struggling with? And yes,
Can you 24 on the 500?
24. This one?
Yes.
Okay, that's fine. We're gonna need some formulas though, before we start it. Even and odd properties, we're gonna need those. So sine of a negative angle is the same as negative sine of the positive angle. Same thing for tangent. And cosecant. Cotangent. All these are the same. These are considered to be odd. The even ones are over here, cosine. If you plug in the negative angle, that's the same as if you plug in a positive. Secant is a reciprocal, so it'll behave the same way. Okay. So we're gonna need those to solve the first few, and we're gonna need some other ones. Let me find it. We need these. They're also in your book, but I don't feel like looking through the book at the moment. So let's write down all these supplemental, because in our question we have plus pi, right? So we're gonna need the ones with plus pi down here. So sine of pi plus some angle is the same as negative sine. Cosine plus an angle is a negative cosine. Tangent plus an angle, pi plus an angle. That just turns into tangent, okay. Cosecant, pi plus an angle is equal to negative cosecant theta. Secant of pi plus theta is equal to negative secant. Cotangent pi plus theta is cotan. All right. I think that's all we need, right? What number was it? It was 5.3, right? 22? No, 24. Okay. And what do they give you? Are your numbers different?
Times sine.
Sine of what? U. What is it equal to?
3/5.
3/5. Anything else they give us? Or is that it? Okay. Then they ask for. Okay, here it is. Oh, I'll also say cosine is negative. Does yours say cosine negative?
Oh, yes.
Okay. So let's first build the triangle. And then we'll start answering the questions. If I put, let's say, u right here, sine of u would be 3/5. And this is one of the magic triangles, so this will be 4. If you try to solve for it, you're going to get 4. They tell us that cosine is negative, so that means that this part is negative. So cosine of u would be negative 4/5. Right? Tangent u is going to be opposite over adjacent, but negative. The next part is sine of negative u. So according to the formula up above, this is the same as negative sine u, which is negative 3/5, right? Raining pretty hard. Nice. Cosine of negative u is the same as cosine, which we already have. Tangent u, negative u. According to the formula, that's an odd function, so it's negative tan of u, which would be negative. Oops, actually, I made a mistake there. Tangent should be 3/4, right?
So for cos negative u is say that negative 4/5.
Yeah, because cosine of negative u is the same as cosine u, because it is even. If you look at the property over here, right? It's the same thing. So just use the same value as before. So negative is positive 3/4. Next part, f. The sine of u plus pi, right? according to the supplemental angles, that's the same as negative sine theta, or in our case, u. Negative sine u we found to be negative 3/5. Cosine u plus pi. That is negative cosine. Actually, u. Negative cosine, so just swap the sign, right, for this one. And then I think there's a tangent, right? Yeah, tangent u plus pi. That's equal to tangent, which we already did. Okay. And then they have the u plus pi over 2. Look at that sheet again. We look at the sheet. I don't think I have the pi over 2, but pretty sure it'll be these. But let's double check. Let's look at their solution, see how they treat those last two. Yeah. So I would just use this as my formula actually. This would be better. We can create our own formula. Because I don't have it. Probably in the book though. All right. Just use these here. You'll be good. Let me write them somewhere though. Gonna jam them in here. Actually, the last one might be wrong. Should be cotang. If you think about it, right? Tangent is the same as sine over cosine. But if I put that u plus pi over 2 in there, they swap, right? So that means that the sine will swap to cosine and the cosine will swap to sine, which means that this is cotangent, not tangent. There we go. So I made you some extra formulas. Good. The last questions were, which I sine of u plus pi over 2, which is the same as sine of cosine of negative u. Give me a second. All right. Just out of space. Sine of u plus pi over 2 is cosine negative u, which we already found. Sine of negative u is right there. And then the last one, of course, will just be the cotan. Anyway, does that make sense? I'll let you get that last one. There you go. I think it's 4/3. But amount of space to work it out. Let's do another problem, unless you guys have any questions on any of these parts. Does this make sense?
Go back to like the.
I'll send this to you too. Not a big deal. Any other problems you're stuck on?
I was doing the one of the water balloon is 5.4. And the angles were different. They were 23 and 27.
Mhm.
So when I did the final division into fraction, I got a negative.
Hmm.
Because it was 1027 divided by 10.
Let me see. It depends. It might be depending on where you put the angles. You maybe have to switch them. Base it.
Yeah, I did.
Being around.
This is already done.
Yeah.
So. Yeah. Whatever you punch in right here. We'll put ranks down. Let me tell you about.
Everything looks good.
Yeah, more like the rational rationalization.
Okay. Whatever. 5.3. Okay. What number was it?
Yeah, it's out.
Which one?
Yeah, but could you do one over?
Yours is one over 8 right here?
Oh,
Yeah.
wait.
It's 14 on such.
Yeah, we'll do that right after
Wait,
this
no,
one.
it's not.
Not this one? This one?
Wait, yes, so.
Here, right?
Down.
This guy? You going?
South.
Oh, this one. Okay.
Yeah, and it's the same.
Everything's the same. Okay, then.
And it's like that weird, you know.
It's 5.4, right? What number was it? 20? So let's do this one, then we'll do that. Her question. Cosine theta is 1/8. First quadrant, so that means everything is positive, right? Okay. So part A cosecant theta. So I'm gonna have to build a triangle. Let me switch over. Cosine is adjacent over hypotenuse. Okay. 8 is 64. 1 squared is 1 minus 64 is 63. So once you build the triangle, cosecant is going to be the reciprocal of sine, right? So it would be 8 over square root 63. Cotangent would be, sort of opposite would be adjacent over that. But then you said you had issues with rationalizing. So multiply top and bottom by that square root. That will force the bottom to be squared. So you get 8 square root 63 over 63. Same thing. Same thing here. These should work.
They try to implement this. So squared plus sine squared. And I got like
It should work that way too.
I had to like I didn't know what it was. But I think it's because like my point is like it's like the cosine like a triangle.
Yeah, so you use the.
You use like this other method.
Can you see that answer again? Square root of 8 squared. Well, that's the same thing I got on the bottom, 1 over root 63. That's what they got for cotan. They just wrote it really weird. The 8 squared minus 1. The 8 squared minus 1 is 63, right? And then the other one, they have 8 squared square rooted, which is an 8. So that's this one. Over 8 squared minus 1, which is again 63. So that's just a strange way to write it. But if you use a sine and cosine, it should work out. Just simplify the numbers and they'll look exactly like this. What was your question?
Oh, I'm sorry, just 14 on like, so this is another.
14, 5.3? Is it this one?
Yes.
Okay.
But mine is 4 and negative.
It's 5.3, what, 14, right? And your numbers are
4 and negative.
okay. If the point to negative sign, sorry. So they didn't tell us if it's on the unit circle, right? So I'm gonna assume it's some circle. We know that all circles centered at 0 can be written this way. The 4 squared plus negative 7 squared equal to the radius squared. That would be 16 plus 49. This is your radius squared. 16 plus 49, that would be what? 65, right? Okay, so square root both sides. R would be square root 65. So sine is on the unit circle is supposed to be just the y value, but since it's not on the unit circle, it's technically y over r. R is always 1 on the circle, so we don't really write it. So it should be negative 7 over root 65. Cosine would be x over r. It should be 4 over root 65.
And then what I think. Would I move the 65 to the?
Yeah, you may have to rationalize. Let's see how they did it. Well, they didn't say exact, so they just used decimals. So you could use either one. Should take it. But yeah, they're using these formulas, which is the r squared for r. Same thing. This might be easier to follow. This one, see. We're just about out of time.